Diophantine equations, example 11.3. In how many ways can 30 coins be comprised of nickels, dimes, and quarters be worth a total of $5? So I'm going to let x equal the number of nickels, y equal the number of dimes, and z equal to the number of quarters. And the two equations that I know is that they all have to add up to 30 because they're 30 coins. And I know that they have to be worth $5. So if each nickel is worth 5 cents, I'm going to use decimals because I mean, if you want to, you can do 1/20th of a dollar, but I think it gets a little more complicated now, so I'm going to start going to decimals. Each dime is 10 cents, and each quarter is 25 cents. So the first thing I want to do is I'm going to multiply everything by 100 to clear my decimals from this second equation. And that's going to give me 5x plus 10y plus 25z equal to 500. And I now am going to divide everything by 5. So ultimately, you know, if you want to, you could have started off just by multiplying everything by 20, and that would have done the job. But sometimes it's hard to see what to do, so sometimes it's easier to just do it in 2 steps. So now that I see that everything is divisible by 5, I'm going to divide everything by 5. So let me do that on the next page. It's basically you're multiplying by everything by 1/5. That was 5x plus 10y plus 25z equal to 500. And when I divide everything by 5, I end up with x plus 2y plus 5z equal to 100. All right, now I'm going to subtract out that first equation. Well, that was equal to 30. Still remembering from the animals. Okay. All right. And this time what I'll be doing is I'll be eliminating the x's. Okay, you want to, again, make sure you eliminate one of these variables. So I'm left with y equal to 4z, excuse me, y plus 4z, y plus 4z equal to 70. So it's really obvious that I'll be solving for y. So I'm just going to subtract 4z from both sides, and I have y equal to 70 minus 4z. All right, I'm ready for my feasibility table. Oops. Now this time, the first thing I'm going to be picking is a z, because that gets plugged into that y equal equation, and then I'll see what kind of y I get. And if that is a feasible solution, a positive integer, then I'll go ahead and I'll get x. Now remember that x can be found because the 3 variables have to add up to 30. So x is going to equal 30 minus y minus z, if we should find one that works. Okay, to figure out where we start with, we're going to just divide 4 into 70 to see what the largest integer that brings. And if I do that, 70 divided by 4 gives me 17 and a half. So I'll just start with the 17, and I'll get going. Okay, so if I plug in 17, 70 minus 4 times 17 is equal to 2. And then 30 minus 2 minus 17 is 11. So there's my first answer. And unlike the example I gave you before where you could count down to your next hit, you can't do that this time because you don't have a denominator. So we're going to have to try them all until we end up with something negative. So when I let a z equal 16, y is equal to 6, and then x is equal to 30 minus 6 minus 16, that's 8. So there's a feasible solution. When I let z equal 15, y is equal to 70 minus 4 times 15, that's 10. And then x would have to equal 30 minus 10 minus 15, that's 5. When I let um, z equal 14, y is equal to 70 minus 4 times 14, that's also 14. So then x would have to equal 2. And then when I let z equal 13, um, y is equal to 70 minus 4 times 13, that's 18. And now x would have to equal negative 1. And there I know to stop because now I'm getting a negative answer. That's no good. All right. So I have no more feasible solutions. So my feasible solutions are, and I guess I have to rewrite this, all right, because this is out of order. 11, 2, 17, 8, 6, 16, 5, 10, 15, and 2, 14, 14. Okay, because those are ordered triples and they have to go in the proper order, X, Y, and Z.